So our next speaker, he supports internal and external key customers in developing their applications using Rockwell automation technology. What I loved when I read it is he loves coding motion functions for customers' applications, applying math and physics, we heard a lot about that, to the industrial automation environment. Mentoring younger engineers, that's one of his passions as well, so sharing his wisdom, and in general, getting connected with people. Well, I say he's at the right place here, definitely. He holds an electrical engineering degree, and that dates back to 1997. That unites it with Maurizio from before. That's also when he started with the business. Please welcome the principal engineer at Rockwell Automation, based in the US, but coming from Bologna, Tommaso Fochi.
Thank you. Thanks to everybody. I'm a little nervous, so please forgive my mistakes. I see if, going through, it will be better. So my name is Tommaso Fochi. I work for Rockwell Automation since almost 20 years, so I almost forgot what my life was before. And Rockwell Automation is not just my company, it really became my family. Okay. This is the agenda for my presentation. I'll try to keep it as short as possible. Just let's start about giving some information about Rockwell Automation. We are a $8 billion company. We are present more or less everywhere in the world. Of course, our home garden is North America, where we have, let's say, where we lead the market. Okay, we are a successful startup. We started in 1903, and I can say we made it. So, my message to the startup guys here is go on. Maybe you will find a company that will last more than 100 years like Rockwell Automation. So we started in 1903 with nothing to do with industrial automation. It came step by step. I'd like just to mention a couple of important dates. 1969, some Allen Bradley components were chosen for the Apollo 11 mission. This makes me very proud. Our first PLC was introduced in the early 70s. And about the mid-90s, we have sold the millionth PLC. At the early 90s, we have already sold 1 million PLC. Now we do PLC, servo drives, and a lot of other stuff, which I do not completely know, because my major focus is motion control. Okay, let's have a quick look at the past, talking about integration of robotics or coordinate system or multi-axis system, let's call it as you want. We started in 2003 with the first coordinate system, so the capability of grouping axes together. Then kinematics followed, so that we could link different type of geometry to the, let's say, multi-axis coordinate system. In 2010, we introduced the motion over Ethernet. Before we had analog cards and then circuits. And then in 2010, we moved to our, it's not our, it's ODVA, to our Ethernet technology. I'm naming also the independent card technology because they will come back later in the presentation, even if they are not related with robotics, but they share a common ground. So in 2015, we introduced the iTrack, and in 2016, we bought Magnemotion, which was a Boston-based company that still do intelligent conveyor system. In 2018, we introduced the Application Code Manager, which is our tool to let's say, store or generate libraries, which we'll see, they will come back later in the presentation. In 2019, we announced our offering of kinematics, getting up to 6-axis linear interpolation. In 2019, we have been acquiring Emulate 3D, which is a digital simulation software. We'll come back later in the presentation. In 2022, we introduced the first release of the robot libraries. We are going to talk about it quickly. And in 2023, we acquired ClearPath, that is a manufacturer of AMR. So this is the latest addition to our portfolio. We are not robot manufacturer, so we don't manufacture any robotic arm, but we try to give our customer the capabilities of driving robotic arms, whether they are, let's say, industrial model or homemade, because we have customers that just build their own kinematics that fits their need. The next chapter is simplifying customer experience and unlocking value with digital tools. This is a copy from a marketing presentation, but don't worry, I'm not gonna kill you with marketing stuff. So I want to talk a little bit about what's the state of the art today, and now we try to help our customer and make their life easier through, I call it hardware and software convergence. I'm not sure that's the right name, but I think it describes well, you know, the fact that real world, control world, and simulation world are more and more connected between them, and how valuable this integration is to deploy more robust project, faster, and more in general that can give benefits to a user, to create, I could have read it, more advanced, efficient system and improved functionality. What else? So let's start from the beginning. Let's take a simple I/O module, nothing special, 8 safety I/O that runs on a safety network. That's the hardware part, and we provide a software object that is related to the hardware module. So it includes already all the functionality of the module, and it's also ready to get connected to the digital twin of it. So you have the hardware component, the control component, and the simulation component. They can run together, or you can have your control connected to the simulation. You can have even an emulation of the control. So possibly you can design and test an automation environment without any other tool than your PC. So you can stay at home, drink a coffee, and program a machine. Let's go to a more complex system. So from a single device, we move to a mechatronic system. In this case, I took the example of an iTrack. An iTrack is a mechatronic system, it's modular, you can add pieces, you can give, you have, okay, some limitation in the shape that you can build, but in general, let's say you have certain flexibility, you can have different number of movers, so let's say it's a system, okay? And just like the device that we talked about before, there's a control object that you can grab from the library tool that we just introduced before. And this object, I wrote low-code reusable object because it's already there. You just need to grab it and put it in your code. configuring it and not. So if we are going in the direction of less programming and more configuration. So you configure your system and you deploy the control content into your application, and it brings with it all the subsystems that, of course, that are managed by the main device handler. So the device handler then manages the other subsystem that belongs to the mechatronic system itself, just grabbing it and put it into your code. And of course, it comes with is simulation twin. So you can build your eye track using standard reusable components. So now we are talking about objects that are ready to go. You just pick them, put them together, and you are ready to go. So you can use your control with the hardware, you can use your control with the simulation, you can use your control with both. You can virtualize a part of the machine so that some parts move physically, other moves virtually, and you can do also the other way around. So you can start from the simulation environment, so you have a set of requirements, you use a simulation environment to validate the application, and from the simulation environment, you can generate the code to be deployed in your controller. Emulate 3D. I don't want to do product advertisements. That's not the case. But let's say our library manager runs in the back of Emulate 3D. So once you have generated your system, you can automatically deploy the library into your project. So you can go in one direction or in the other direction. It's the same. It's up to you. Now we move to robot, which is, let's say, the topic of this meeting. And you will see how the concept stays very similar. We have two paths to getting more from your robots. Unified robot control, that means the robot is controlled directly by the Rockwell PLC. It's fun to call it a PLC because it's much, let's say, automation controller today are much more than what a programmable logic controller used to be. We also try to give it a different name. So instead of calling PLC, we try to call it PAC for a while. So programmable automation controller. But this PLC name is in everybody's head, and it stays there. Not a problem. So you can control a robot directly from the system, or you can have, we call it Ethernet IP connected, so drive a robot through network. Profibus is a great network, but Ethernet IP is not bad as well. And let's say, because we are involved in the network connection of industrial robot, of course, we are interested in SRCI. So we are joining the working group, and we will participate we can in the definition and in development of the next phases of the SRCI. These are the supported geometries. I will not bother you with this. These are, let's say, our official partner networks. Some of them provide mechanics that goes directly controlled by the PLC. Others are partners that we can connect through network. But let's go on. And we return from what we were few slides before. So what is a robot? The robot is a mechatronic system, again. And you want to, in particular, we have, for this type of application, we have a partnership with Comau. So you can select a specific hardware from the platform, from the partner catalog. And guess what? You have the corresponding device handler that you grab from the library. Again, configuration and not programming. You just need to tell what type of robot it is. In case of a partner robot, it brings along everything. So he knows the dimension, he knows the physical properties, he knows the motors, everything. So you take your robot module, you put it into the controller, he brings along all the subsystems, so you don't have to worry about drives, configuration, motors, because they all come with the robot module. And of course, you can link it to the simulation environment. Again, using standard, ready-to-go, reusable component. So let's say you can really start building your application without writing a line of code so far. Of course, at a certain point, you will be required to write some code. But so far, you have done nothing that specifying a catalog number, specifying the configuration of your truck or whatever it is, and boom, everything is generated and fully working. And of course, also here, you can do the opposite. So you can start working in the simulation environment and using then the libraries that lies behind, generate your control device that is ready to be downloaded to the PLC. And of course, you can put all these things together. So you can have a robot that is working with a truck, that receive inputs from a module, and you have taken all these modules, put them together, and you have built, let's say, the infrastructure of your code, just grabbing devices from the library. You can combine virtual and physical environment. You can leverage the standard reusable components. You can validate application in a simulation environment. You can develop and test code in a more robust way. And in the end, you can save precious time. This is not always understood especially by the smaller OEMs, which are always in a hurry. They are always late with their project. And sometimes they think that sitting on the desk playing with a simulation environment may be a waste of time. You should be on the machine making it run. But the reality is that the work that you do in the simulation environment will be super precious later on, and not just in the commissioning phase. It can be used, in post-sales application. If any customer reports an issue or a problem, you can help them troubleshooting simply using the virtual system. If the machine is not completely built, you can virtualize a part of it and keep the other one real. So there's a number of possibilities that the new digital tools that I believe every PLC vendor today is offering to their customer to work better, save time, and make more robust project. Done.
Thank you.
Finito. Finito.
You did it in half.
I can get a beer now.
A Negroni, maybe.
No, it's not the right time. And,
So you did that in half the amount of words that Maurizio used, because he said, that's it. And you just said, done.
Done, okay.
Wow. By the way, who did your marketing slides, the fancy ones? Was it you? Was it Roberta?
Yeah, it was a collaboration between me and Roberta.
We noticed the AC/DC reference.
Oh, yes, because I love rock and roll.
Ah, okay.
In between the many things that I love.
Because I thought you were going to add, like, for those about to rock, well...
Right, I thought...
Hard as a rock, well...
Right,
You missed an opportunity.
You are totally right. I thought about adding additional references, but then I want also to give serious impression and not just let you know how full am I immediately.
That's fair enough. Do we have any questions in the audience to Tommaso? You've overwhelmed them.
Good.
Yes. I knew it. Thank you, Bertus.
You we trust.
Please. But he's a friend, so...
That's right. So I was... thank you for this great and entertaining presentation. You're really excellent. So I was a bit surprised to see. I mean, I've used Rockwell. I did Rockwell programming before I joined Yaskawa for many years, but that was until, let's say, 2012. But at that time, I think there were already some simple kinematics. Now I even see the 6-axis. So yeah, that can work fully synchronous with also with the eye-track system? Or?
Absolutely.
Yeah.
It can work synchronously with all other devices that are controlled in the PLC.
Yeah.
That's one of the great advantage of, of course, the capabilities of the PLC are, I'm very honest and open with you, are not comparable with the feature that an industrial robot controller can deliver. We are not competing on the same application. But the great advantage is to have everything in one system, everything synchronized, and everything coordinated.
Yeah.
So the answer to your question is yes.
Yeah, and just to get an idea, what's the amount of robots which could run in by one PLC synchronously?
Let's say it depends on a number of things. I will say that, for example, 6-8 robots could fit in a single controller, but then you might have no space left for other things, because maybe you don't have just the robots. You want to have maybe 2 robots, an eye track, and then you have all the periphery to manage. So it really depends on how much stuff you put in it and which type of performance you ask to every single devices.
Thank you. Then I got one more question. And
Please.
That's, more SSCI related.
So far they were easy, so...
Yeah, it's just a starter. You mentioned that considering or investigating SSCI. Looking at the Rockwell programming environment, do you see any difficulties or challenges when it comes to implementing SSCI, or is it just hard work, but no?
No, I don't see any difficulty. We just need to understand in which way we want to deliver that to the customer. So if you want to deliver it in forms of firmware, if we want to deliver it in form of application code, or as a parallel task, we haven't decided yet. We are investigating it, but I see no problems in integrating SRCI inside our controller.
Excellent. Thank you.
Okay. Thank you.
Basta.
Thank you. Any other questions? We might be able to fit one more in. No? Bertus has covered that all pretty well for all of us. Thank you so much.
You know, we went out last night and we agreed on the question.
Yeah, I thought so. I thought you might.
It worked.
Thank you so much. Thank you.
Thank you.
Thank you.